Welcome to BGP series, BGP Border Gateway Protocol. This is day 3. This is your video number 3rd. I had uploaded 2 videos, right? So in first video, I had discussed why we come up with BGP. Why we come up with BGP, right? So why BGP? So what the problem was there with IGP protocol? Interior Gateway Protocol just like RIP, EIGRP and OSPF. So what's the problem with these protocols? So why we come up with BGP? BGP is actually EGP. BGP is EGP, Exterior Gateway Protocol, right? Exterior Gateway Protocol. So why we come up with BGP? Because IGP protocols can't handle more than 100 prefixes in their routing tables, right? IGP protocol can't handle more than 1000 root in their routing table, right? So first problem is you can't implement IGP protocols in large network, right? So we need BGP in large network, right? Second reason why we come up with BGP, actually your IGP protocols work within AS, within autonomous system, right? So suppose if we have 2 routers, this is my R1 and this is my R2. So this router belongs to different AS and this router belongs to different AS. Just suppose I am using AS number 100 over here and 200 over here, right? So we can't form neighborship between R1 and R2 if I am using IGP, right? If I am using OSPF or EIGRP, right? Because these protocols work within autonomous system, right? Autonomous system must match, right? Then only they will form neighbor between 2 routers, right? But in BGP, in exterior gateway protocols, we can form neighborship, we can discover neighborship between different AS as well, right? So second use of BGP and second reason of BGP, why we come up with BGP is we can form neighborship with different AS as well, okay? So today and day 2, in day 2 I had discussed where you should use BGP, right? Types of network. And today in day 3 I am going to show you types of messages in BGP, types of messages in BGP, okay? After that, so your first topic, after that I will show you how to configure basic BGP, right? Like Ebgp and IBGP, right? So guys, make sure you are very clear with why we come up with BGP, why you are learning BGP, why I am using BGP in network, right? So you need to understand, you need to have basic knowledge, right? If you don't know why I am using BGP and where you should use BGP, just watch my first and second video first, then watch this video, okay? So let's start. So I am going to discuss types of messages in BGP and how to configure Ebgp and IBGP. Ebgp is exterior border gateway protocol, right? When we configure BGP with different AS, right? And IBGP stands for interior border gateway protocols. So when AS number will same, just suppose this is my R1, this is my R2, and R1 is using AS number 100 and R2 is also using AS number 100, right? Then we will implement IBGP over here. But if this router is using 200, AS number 200, then we will implement Ebgp over here, fine? And the third thing which I am going to discuss today is, what are the content in message, just like in open message, what will be the information, right? So what I am going to do, I will take 2 routers in GNS3 and then I will capture this link, right? Then I will capture this link. So the traffic, the message of BGP will go from R1 to R2. The message will capture in my capturing unit, and then I will show you each and everything. Okay, so be patient, watch the video till the end. Let's start. Okay, so first topic is today I am going to cover three topics, right? Types of messages, how to configure basic BGP, right? And what are the content in message, right? In open message, what will be the information there? In keep alive message, what will be the information there, right? So guys, first type of message in BGP is open message. Open message. Okay. Second type of message is keep alive message. Keep alive message. Third type of message in BGP is update message. Update. And fourth one is notification message. Notification. Guys, my writing is clear. If my writing is not clear, if you are not able to read, please let me know in comment. And if you are able to read, please let me in comment as well, right? If you are not able, then definitely in next video, in upcoming video, I will write more clearly. Okay. And fifth type of message is route refresh. Route refresh. So I am going to discuss these three types of message today. And in next video, I will discuss this notification message and route refresh message. Okay, because if I cover these all messages in single video, then it's very difficult for you to watch complete video, right? It will be complicated. Okay, because the length of video will be very large. So first type of message is open message. Open message. Second message is keep alive. Okay, just keep alive. Guys, you remember IGP protocol? IGP just like OSPF, right? There was one message, hello message, right? So what was the use of hello message there in OSPF? To discover neighborship, right? To discover neighbor between two router, and keep alive, right? To keep neighbor updated. Right, so there was two use of hello message in IGP protocol in OSPF. Fine. Now in BGP, these two messages will do the same work that hello message was doing in OSPF. Fine, the same message. Open message will discover neighbor. Open message will discover neighbor or for neighbor, and keep alive message will keep updated your neighbor. Okay. Keep alive message will use to keep updated neighbor. Fine. Okay. Let me make you more clear. So suppose I have two routers R1 and R2. Suppose I am using IP address over here is 12.1.1.1/24 and here 12.1.1.2/24. Okay. So guys, you know BGP is a layer 7 protocol, right? I had discussed in day 1. BGP is application layer protocol, right? So traffic will generate at application layer, but BGP use TCP at transport layer. So before sending actual BGP traffic, right, transport layer will build a connection between R1 and R2, right? Build a connection, establish the connection by three-way handshake, right? As you remember, I discussed in TCP header, right? In TCP header and at transport layer, when I was teaching you transport layer, right? I had discussed that all service which will use TCP, they will build a connection with remote device before sending actual data. Am I right? So R1 will build a connection with R2, right? Before sending BGP message. Okay. So BGP is a layer 7 protocol, and protocol number of BGP is protocol number is 179. Am I right? Protocol number is 179. Fine. So I will configure BGP static. I will configure a static neighborship between R1 and R2. So I have to say to R1 that your neighbor is 12.1.1.2, and I have to tell to R2 as well that your neighbor is 12.1.1.1, right? I will show you how to configure a static neighborship between two routers R1 and R2. I will show you everything on packet tracer in GNS3. Just keep this thing aside for a moment, right? So guys, when connection will establish between R1 and R2 at transport layer, right? So what transport layer is going to add over here is source port. So source port will be any random number. Just suppose I am using 1025, and destination port will be well-known port number, right? Protocol number of port number of BGP 179. Am I right? And there will be one field scene bit. So scene bit will be 1, right? So this router will came to know that yes, this machine is trying to build a connection with me, so I have to acknowledge. If you remember three-way handshake, right? If you remember three-way handshake, so this PC will send scene, and then this PC will send scene plus ACK, and then this server will send scene plus ACK, and then this PC will send ACK, acknowledgement, right? Okay. So before sending actual data of BGP, right, R1 will build a connection with R2. Okay. So for building connection, R1 is using source port number 1025 and destination port number 179. Okay. Then transport layer will hand over this TCP message to, this is a TCP message, right? So this TCP message will hand over to network layer, and network layer will add source IP. So source IP will be 12.1.1.1. Destination IP will be 12.1.1.2, and there will be one field called protocol field, and the number will be 6 in protocol field. That means I am using TCP at transport layer, right? Now network layer will hand over this traffic, this packet to data link layer, and data link layer will add data link header. So I am using serial link between R1 and R2. So data link layer will add HDLC header. Okay. Then this traffic will receive by, this frame will receive by R2, right? Guys, this router R1 and R2 will maintain a table called TCB table, right? TCB table, transmission control block. Okay. And what will be the information in TCB table? Just like IP address of interface of R1, so 12.1.1.1, and I am using port number 1025 for 12.1.1.1, and my neighbor is 12.1.1.2. right? My remote device is 12.2, and I am using port number for 12.2 is 179. In the same way, R2 will also maintain this table, TCB table, and the information will be 12.1.1.2, port number will be 179, and 12.1.1.1 port number will be 1025. Okay, TCB table. Fine. Now when this machine will receive this traffic at network layer, it will check destination IP address. So destination IP address is 12.2. So yes, it's for me. Let me check further information. Protocol number is 6. So I have to hand over this traffic to TCP at layer 4. So network layer will hand over this traffic to transport layer. Now transport layer will check destination port number. So destination port number is 179. That means see a message of BGP, and there is scene bit on. That means this machine is trying to build a connection with me, right? So I have to reply. So R2 will generate TCP message, right? Where source port will be 179, destination port will be 1025, right? And scene bit will be 1, and acknowledgement will also set as 1, right? Now transport layer will hand over this to network layer. Network layer will add source IP 12.2, destination IP 12.1, right? And protocol 6, and then network layer will hand over this to data link layer. Data link layer will add HD LC header, right? And then this traffic will goes from R2 to R1. Now R1 will check destination IP address is 12.1 and protocol number is 6. So R1 will hand over this packet to this segment. Actually, this is a TCP message, right? This is a TCP message. So this TCP message to transport layer. Now transport layer will check destination port number, right? Destination port number will be 1025, and there is one entry in TCP table that for 12.1.1.2 I am using port number 179. Then this router will came to know that yes, it's a reply, right? It's an acknowledgement and SYN bit is on. So that means connection is fine. Connection will build. So R1 will again send one message with SYN bit, right? Sorry, not SYN bit, acknowledgement bit, right? With acknowledgement bit. I will show you each and everything in packet tracer. Don't worry about that. Just let me clear you your basic first, right? So this will how connection will build, connection will form between R1 and R2. After building connection, R1 will send open message. R1 will send open message to R2, right? So open message will send only once, right? And after 60 seconds, after every 60 seconds, this router will send a keep alive to R2, and R2 will also send a keep alive to R1 to keep neighborship updated, right? But open message will send at once, only once, right? Open message is not sent periodically, right? Just like hello packet, right? Hello packet was sent periodically after a certain interval of time, right? But open message will send once. Okay, so R1 and R2 is build a connection, right? So R1 is using port number 1025 and R2 is using port number 179. So guys, when connection will terminate, then only source port and destination port will be changed. Then only source port will change, right? Not destination port will change. Destination port will always 179. But when connection is stabilized, right? Until then, this connection will maintain the port number will be same, right? R1 will use 1025 and R2 will use 179. Okay, so let me end this and let me open packet tracer first to make you understand. Okay, so as you can see over here, we have two router, right? And I am running network 12.1.1.0/24 between R1 and R2. So first of all, let me configure IP address on the interface of router. Okay, first of all, configure IP address on the interface of router. So interface fast Ethernet, no fast Ethernet, serial 2x0, no shutdown, and IP address. IP address is 12.1.1.1. Submit mask is 255.255.255.0. Fine. Let me configure IP address on R2 as well. Let me access R2. Configure terminal. Interface serial 2x0, no shutdown. IP address 12.1.1.2 255.255.255.0. okay, exit. Let me check neighbor, CDP neighbor. So CDP neighbor, so R1 is neighbor of R2, right? Now I am able to ping my neighbor. Let me check 12.1.1.1. Yes, I am able to ping my neighbor. Okay, now I'm going to configure eBGP on R1 and R2, and I am going to running AS number 100 on R1 and AS number 200 to R2. So AS number is different. So we will configure eBGP over here, right? Now let me access R1. The command is same, router BGP. Autonomous system number is 100. Right? Now I have to say your